Okay, this is the video for average atomic mass. Now, what I'd like you to do is get out a periodic table. If you do not have a periodic table, there is a link above the right side of your table of contents. Okay, it says periodic table download. Go ahead and click on that so you can download the periodic table and take a look at it while you are watching this video. Open it up in another tab or another window so you can kind of follow along as we go. I'm going to go ahead and use an example of copper. So let's go ahead and take a look at copper and take a look at your periodic table. Now you notice, like copper, there are very few elements that are on the periodic table that have a mass number that is near a whole number. Okay, so if I was to take a look, let's go ahead and identify some of these pieces. Okay, this right here is the mass number. We remember from the last video, this is the number of protons and the number of neutrons. Now, this mass number, okay, is the average atomic mass, meaning we all know that there are isotopes, and this would be the average of the isotopes, okay, of the different masses of those isotopes. So this right here represents the mass number. This would be the average. Now, the reason why the mass of a particular atom is, or at least the masses on the periodic table, are not whole numbers is because, like I said, they are averages. And they're not just any type of averages, they're weighted averages. Okay? In which the weighted averages of the weights of these different naturally occurring isotopes of an element. Okay, so what I mean by that is, let's go ahead and take a look at, with the copper, 63.546. This is assuming, okay, like when you guys normally do an average, so let's go ahead and take a look at a normal average that you guys would do, say, in your math class, or calculating a mean, okay? If I wanted to know the average percentage on an exam, so I'm going to go ahead and say 52%, 97%, and then 72%. So if I wanted to find the average percentage on this exam of these three students, okay, let's go ahead and say, or let's how about this? Say this is exam 1, this is exam 2, and this is exam 3 for any particular student. Let's go ahead and say student X, okay? And student X, I want to know what his average or her average test score is. So what I would do is I would go ahead and say 52 plus 97 plus 72. And I would get 2, let's see here, 1, 2, so 221. And then I would divide that, okay, so I take this right here, 221, and I would divide it by the total number of samples, in this case, 1, 2, 3, and my average would be 73 in this case, 73.7%. That would be the average, okay? This is assuming, okay, calculating this type of average, this is a non-weighted average, meaning all trials, this trial here, E1, E2, and E3, they occur in equal amounts, meaning there was one instance here, one instance here, one instance here. Well, when we calculate the average atomic mass, those are weighted averages. So let's say I had, let's go and erase this real quick. Let's say I had 2 different isotopes of copper. Okay, so that copper would be, let's see, copper 63 and copper 65. Okay, this is just an example. It may or may not turn out to be this average atomic mass. Okay, but this is just an example. So I had copper 63 and copper 65. If they were both occurring in equal abundance, meaning of all the copper in the world, half of it, meaning 50% of it would be copper 63 and 50% of it would be copper 65, then what I would do is I would calculate an average like I normally would with, calculating, adding up all the trials and then dividing it by the number of trials. Okay? Now, so how you calculate averages in for average atomic mass in chemistry is a little different. The math will all work out if you did it another way with your normal averages. You know, if we did that average the same way. But in this case, like I said, we're going to do a little different. What we need to know are two things. We need to know the mass, which in this case would be 63 and 65, and we also need to know the abundance, or how much that particular isotope is present in the environment. So 50, or in existence, 50-50. So if I wanted to find out what the average atomic mass would be, I would take the percentage. Okay, so the first step is going to be, I'm going to take the percentage and I'm going to divide it by 100 to get a decimal. Okay, so if I was to take this right here, this would be 0.5, and this would be 0.5. All right, so those are my decimals, so that'd be step one. Step two is I'm going to multiply that decimal by the mass of the isotope. So for example, if I was to go ahead and go down a little more, I'm going to go that decimal for the first one. Okay, so let's go 63 times 0.5. Okay, and I'm going to add it to the product of the other mass, 65, times the other decimal. Okay, and doing this right here would be I'm going to end up having the same answer as if I added them up and then added 63 and 65 and divided by 2. So let's go ahead and do the math real quick. Okay, so if I was to take 63 times 0.5, which would be the same thing as taking 63 and dividing it by 2, I'd get 31.50. And then if I have 65 divided by half, or divided by 2 or multiplied by half, I would get 32.5. I add those two things together, and this is my average atomic mass for copper. Now, is it the true average atomic mass for copper? No, the true average would be 63.54. Okay, according to this set of data, it would be 64.00 AMUs. Now, just so we know, and we're not confused by any means, okay, sig figs. Do not worry about them right here. All I want you to do is, when you're done with this product and you're done with this product, that your answer has two go to the hundredths place, and I want your final answer to be to the hundredths place. You do not need to worry about sig figs right here, okay? So let's go ahead and take a look at another example. This time I have chlorine, okay? Now there's two isotopes of chlorine. There's chlorine 37 and there's chlorine 35. And of all of the chlorine atoms in nature, okay, 75% of it is chlorine 35, and only 25% of it is chlorine 37. Now this is not an even average, so what I have to do is I have to do my steps. My first step being change this into a decimal, 0.25. Change this into a decimal, 0.25, excuse me, 75. Okay, that looks like a 4. Let me change that. 0.75. And then I'm going to multiply this number by this number. And then this number by this number. And then add them together. Okay, this is how I'm going to calculate a weighted average. So I'd go 37 times 0.25. And I'm going to add, okay, let's see, 35 times 0.75. Go ahead and do the math. And that'd be 9.25. And then this one would be 26.25. And then when I add those two together, I'm going to end up with 35.50 AMUs. And then that's my average atomic mass according to this data. All right? I will have another video with more examples. but this should be able to get you through the worksheet.